Howdy, my name is Matthew Gimlin, and today I'm going to be showing you how to draw a Lewis dot structure. As you can see with the two valence electrons on the eye there. For this experiment, we're going to be using carbon dioxide, and as you can see, we have carbon in group 4 and oxygen in group 6. It's going to come in handy later. So our first step in drawing a Lewis dot structure is to count the total valence electrons. As you can see in the properly formatted table there in the middle, carbon has 4 valence electrons and oxygen has 2 valence electrons. It's important to keep note that there's 2 oxygens in carbon dioxide, so the total comes out to 16 valence electrons. And for the second step, we're going to determine the central atom, which again in the properly formatted table, we can see the electronegativities, and the central atom is going to be the one that has the lowest electronegativity. So in this case, it's carbon with 2.55. So now that we have the valence electrons and the central atom of carbon, we can begin with step 3, which is to connect the outer atoms to the central ones. So you might be asking what that did. What we did there is just create a bond, which is not the type of bond pictured here. It's actually a chemical bond. So after that, the next step 4 is to fill the octets of the outer electrons. To make the octet basically just to make sure each outer atom has 8 electrons, so it's happy. And the 5th step is to create additional bonds as needed. So as you can see in the previous step, carbon only had 2 bonds, so only had 4 valence electrons. So we need to take 2 pairs of valence electrons from the oxygens and create an additional bond for each oxygen, so that way carbon is happy with its octet. So now all atoms have 8 electrons or valence electrons, so all the atoms are happy. There is a step 6, which is just to be aware of any octet rule violators. Here's some common ones. Hydrogen only has 2 valence electrons, and there's some electrons like beryllium, which only requires 4, boron, which only needs 6, and some atoms like phosphorus can take as many as 10 valence electrons. So thank you for listening to my experiment, and gig 'em.